In this video, I'm going to be going through how to do bolt shear. And so the first thing we need to look at is we need to look at whether or not it's in double or single shear. I covered that double, single or triple shear. I covered that a little bit at the end of my last video. What we can look at in this case is that this bolt is in double shear. The idea is that if we start from the top, we go left, 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 right, 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 left, left, left. We change direction twice. We'll just quickly draw up that if I have a bolt like this, I'm just drawing the line for the bolt, that would be single shear. And here I have how many changes of direction. I'm just drawing that for the bolt. 1, 2, 3 changes, so that would be triple shear. Theoretically, we could have quadruple shear if we had a coupling. Sometimes you have couplings that have 2 go into 3, and that would be quadruple shear. So I'll just write above that. So that's single shear and double shear. Okay, in our question here, what we have is double shear, and it's pretty good advice that if they have a question like this, it's very likely to be double shear. I'm not saying that definitively, but double shear certainly seems more common. So if in doubt, that would probably be where I would land. So in our situation here, so what we know is stress equals force over area. What I've done is I've rearranged that formula, so I've swapped stress and area. So area and stress have swapped locations. We've been given that the force is 10 kilonewtons. So some students get confused that there's 5 on this side, 2 lots of 5 versus the 10. But in this case, we can think of it's 10 and 10 on both sides. So it's 10 is the force we're using. The allowable stress, or the strength of the material, maybe the factored strength of material, is 300 megapascals. But what we don't have is the area. So we're going to be working out, we've got this formula here for area, but what I want to focus on is that because it's double shear, and I'd actually write that down. I would say, if you write that down, you're showing the marker that you know what you're doing. So maybe if this was a 3-mark question, that could possibly be enough to get you 2 marks. I don't know, I can't say definitively, but that could be enough to get you 2 marks. So what I want you to remember is that when we do our formula, it's actually 2a, because it's double shear, equals 10 times 10 to the 3 divided by 30. I'm using megapascals because we go together like megapascals and millimeters squared, which means our answer is going to be millimeters squared. And our 2 area is going to be, so it's going to be 10, 1, 2, 3 zeros divided by 30 equals 333. Then I'm going to divide by 2 and say, I'll write that here. So therefore, A equals 1/6. We'll round up to the nearest millimeter squared. Okay, the next thing I have here is I have a formula for remembering area. Now, I will say that when I was in high school, I always used pi r squared. It's what everyone did. It wasn't really until I started working, I think that I shifted to the pi d squared on 4. It's just because we want to find diameter, and if you're using radius, it's very easy to get confused. I'll just leave it at that. So what we can say here is, well, we want the 4, we're going to multiply both sides by 4, so the 4 goes up here. We're going to divide both sides by pi, and that leaves us with d squared. So that means that d is going to equal the square root of 4a divided by pi. And we're remembering that we're using double shear, because if you forget that it's double shear, you're going to have a problem. So what we're going to have is our answer is going to be 4 times 1.67. In my case, I'm just using the answer button. 4 times that number divided by pi equals this, and then I'm going to square root that answer, and I get an answer of d equals 14.6 millimeters squared. And that is the same answer that Copeland gets. So that's how we approach bolt shear. The ribbon shear will be either attached to this or in a separate video. Okay, thanks.